For this practice example, we're going to name 4 binary molecular compounds, which are given here. Our first step in any nomenclature problem will be to figure out what type of compound we have. We're in the molecular nomenclature section, and this question tells us that these are binary molecular compounds, but confirming that we know these compounds are what they are supposed to be will deepen our understanding of the material. Recall that binary molecular compounds will consist of 2 types of non-metal elements. If you look up all of the elements listed here, you'll see that they are all up and to the right of the stair step on the periodic table, with the exception of hydrogen. Everything in this area of the periodic table is a non-metal, so these elements can form molecular compounds. In regards to hydrogen, it is placed above the first column on the periodic table because it most commonly forms the same 1+ ion that the elements below it does. But it really could also be placed above fluorine because it is also capable of forming a 1- ion. Since that latter is true, and since hydrogen has no properties characteristic to metal samples, it's considered a non-metal. You'll want to work to remember that since it sometimes trips students up. Now that we have identified our compounds as binary molecular compounds, we need to refresh our memory on the naming rules. Since binary compounds are composed of nonmetals, and since nonmetals can often come together in the same pairing, but with different ratios of the 2 atoms involved, we have to tell the chemist not only what is present in our compound, but also how many of that thing are present when we come up with a compound name. There are really 4 parts to the name of any binary molecular compound. The first part is the name of the first element in the formula. Just the name, don't do anything to it. If hydrogen is first, then you will use hydrogen. If carbon is first, then you will use carbon, and so on. Our second job is to include how many of that first element there are. This is where the table of prefixes will come in. If there are 2 hydrogens, then we will add the prefix to indicate 2, which is di, before the name of that element. This would give us dihydrogen. Always the prefix first and then the name. No space in between those 2. There are a few sticking points here. First, if we happen to have an element whose name starts with a vowel, such as oxygen or iodine, and we happen to have a prefix that ends with a vowel, then we will drop the vowel on that prefix. We won't squish both vowels together. For example, we would not write pentaoxide, we would write pentoxide. Our second sticking point, and this one is bigger, is that if there is a single atom of the first element, then we will not use the prefix. I'll elaborate on this when we get to our first example. On to the third part of our name, which requires us to name the second element in our compound and to indicate that we are for sure that it is the second element. The elements in a molecular compound appear in the formula in a certain order. The one that will have less electron density around it, more on this later, please don't panic, will always come first, and the one that has more electron density around it, remain calm, will come second. The easy button here to identifying the most electronegative element is determine which is closer to fluorine on the periodic table. Take a minute to look at all 4 of the examples we are going to name. In all 4 cases, the element that is furthest away from fluorine is first in every case, and the one that is closest to fluorine is second in every case, in every single one. The majority of you likely saying, why are you still on this giant side quest, Dr. E? Because I'm trying to explain why we use a special ending for the element that comes second. Instead of using simply the name of the second element, we use a modified version of that name. See the table in the section that has the IDE endings. This ending lets the chemist know that you are talking about the atom that is pulling more of the electrons in a bond towards itself. So instead of oxygen, we will have oxide. Instead of chlorine, chloride. Rinse, repeat. The last part of our 4-part name will tell the chemist how many of that second element there are. Here we will still use the rule about not putting 2 vowels together that we talked about with the first part of the name. But unlike the first part, we will always use a prefix to indicate how many of that second element are present, even if there only happens to be 1. These rules are given in the content page, and I suggest you pull that page up while we are naming these 4 compounds so that you can get better used to the systematic process. Our first element is carbon, so we will start there. There's only one of this first element, so we will not need a prefix in front of the carbon. Our second element is oxygen, but oxygen is the more electronegative of these two, which is why it comes second here, and we need to tell the chemist that wasn't an accident. We do that by changing the ending of the element's name to IDE. Instead of including oxygen in the name, we will use oxide. Lastly, we have to let the chemist know that there are 2 oxygen atoms in this molecule. The prefix for 2 is di, so we will place that in front of the oxide. There are 4 parts to our process, but there are only 2 parts to our name. The prefix in the name for the first element is a single word. The prefix in the name for the second element is also a single but separate word. Those 2 words are separated by 1 single space. Last sticking point, our compounds are not proper nouns, unless a compound name is located at the very beginning of a sentence. When entering names of compounds into the homework or quizzes, both pieces should be lowercase. The first element in our compound is chlorine. There is a single chlorine in this molecule. Since chlorine is the first element and there is only one, we will not use a prefix. Our second element is fluorine, but since it comes second, we denote that with an IDE ending. We should use fluoride here. Do be careful spelling fluorine or fluoride. You've spelled the word flower for many years, so your default will be to place the O before the U. But fluorine doesn't care about your flower, and the U is in front of the O. This is probably the most common spelling error on our quizzes. Lastly, there are 5 atoms of fluorine in this molecule. The prefix for 5 is penta, so we will add that before the fluoride. The name of this compound, therefore, is chlorine pentafluoride. Our first atom is hydrogen. There are 2 hydrogen atoms. We need to use the di prefix here. Second element is oxygen, so we need to use the term oxide. There is a single oxygen atom in this compound, so we will use the prefix mono. Remember that we will only drop the prefix for the first atom. We will always include the prefix for a second atom, even if there is just one. The name of this compound, therefore, is dihydrogen monoxide. Be careful. The biggest trick in molecular nomenclature is on this slide. Notice that the prefix for mono is MONO, but we only included MON here. It sounds goofy and is a touch tricky to pronounce the O from the prefix before the O from the oxygen. So we drop the O at the end of the prefix and simply call this monoxide instead of monooxide. The same is true for the prefixes that end with A. Instead of tetraoxide, we would simply say tetroxide. Do not drop the I at the end of di or tri, though. We will still have dioxide and trioxide. We limit this dropping to O and A endings. Our first element is nitrogen. There are 2 nitrogen atoms in this compound, which will require the prefix di. Our second element is oxygen, so our second word will include oxide. There are 5 oxygen atoms in this one molecule. The prefix for 5 is penta, but we need to be careful about the vowel rule we saw in the last example. Instead of pentaoxide, you will need to drop the A off the prefix and simply include pentoxide. So this molecule is named dinitrogen pentoxide.